In this video, we are going to discuss question 6.42. The question says a cannonball of mass 5.99 kilogram is shot from a cannon at an angle of 50.21 relative to the horizontal and with an initial speed of 52.61 meter per second. As the cannonball reaches its highest point of trajectory, what is the gain in its potential energy relative to the point from which it was shot? So let us sketch the question first. I will take this as my starting point. This is where I will place my cannon. And you shot a cannonball from here. Cannonball follows a parabolic path. The initial angle at which it's been shot at is 50.21 theta. And the velocity, initial velocity with which the cannon was shot, I will write it as V0, which is 52.61. And the angle theta was 50.21. I need to find what is the gain in potential energy at the highest point. So highest point is this point over here, the highest point on the trajectory. We need to find what's the potential energy at this point. Now, for projectile motion, it has two components of velocity, y component and the x component. In this question, my initial velocity with which the projectile is launched, with which the cannonball is launched, has both components. It has an x component and a y component. At the highest point, however, y component of velocity become equal to 0. Only the y component, because it is similar to free fall motion. X component, on the other hand, x component of velocity in projectile motion does not change. It remains constant. So even though the y component is 0, x component still remains at the highest point, and we write the x component as v cosine theta. This is how you find x component of any vector, by multiplying the magnitude of vector with cosine of the angle theta. So at this initial point, I have velocity v0, which is the resultant of both x and y component at that point. On the highest point, I have only the x component. Y component of velocity at that point will be 0. Let h be the height at the maximum, the highest point. I need to find what is the gain in potential energy over here. Now, according to law of conservation of energy, total energy at any point in motion in an isolated system always remains constant. If the energy remains constant, that means any change in energy must be 0. Because if energy at every point is constant, when I subtract energy from any two points, that change must be 0. So change in mechanical energy can be written as change in kinetic plus change in potential energy. And this change in energy, according to law of conservation of energy, must be equal to 0. So using this expression, I can write my change in potential energy is equal to negative of change in kinetic energy, which you can get by just moving this kinetic energy to the other side. Since delta K is positive here, when I move it to other side, it becomes negative. Now change in kinetic energy you can write as final minus initial value. And when I open the bracket to include the negative sign, K final becomes minus, minus and minus will become plus here. So you get K initial minus K final. Now I can subtract initial and final kinetic energy between these 2 points to get my gain in potential energy. So delta U will be equal to half mv initial squared minus half mv final squared. Now my v final is nothing but the x component of velocity at the highest point. So I will write that as half m x component is v0 cosine theta. So v0 squared cosine theta squared. In these two expressions, in these two terms over here, half mv naught squared is common. This term here has half mv naught squared, first term, and the second term also has half mv naught squared. So I can take that as common. So delta U will be half mv naught squared 1 minus, since here you have only half mv naught squared, I will write 1 here, minus, this term has cosine squared theta. So this is my final expression to calculate the gain in potential energy. Now I will substitute my values here to get the final answer. So let's substitute. We will write delta U equals half. Mass of the cannonball is 5.99. V initial is 52.61 squared, bracket 1 minus cosine square. The angle is 50.21. Now when you substitute, when you calculate the answer comes out to be 4894.4 joule. This is the gain in potential energy at that point. So you can use similar expression. You can solve it in a similar fashion if they ask you to find gain in potential energy at any other point. Except when you are considering any other point, you will have both component of velocity. You will have a y component and you will have an x component. At the highest point, on the other hand, x component exists, y component is 0. And x component exists because in projectile motion, x component of velocity remains constant. Remember, this is not just free fall, this is projectile. In free fall motion, generally when we consider free fall motion, we take velocity at the highest point to be equal to 0. But projectile motion is a combination of motion along x-axis as well as motion along y-axis. So y-axis motion is similar to free fall. This is why y component of velocity becomes 0 at the highest point, but x component remains constant. It does not change. So whatever initial x velocity you had over here, that x component will be the same throughout the motion.